water. It's so hot outside. I need water.
My bad. I don't got any water, Twin. Are you always tired of the sun messing up your day? Well, don't give it too much hate. The sun is actually the primary energy generator for the entire Earth. But most of our energy consumption goes through fossil fuels, which is extremely problematic for two main reasons. One, fossil fuels emit greenhouse gases and have catastrophic carbon footprints, harming our environment and contributing to global warming. Two, we're likely going to run out of fossil fuels in the next 50 or so years. So, what's the solution? The solution is we have to switch to renewable energy, the most prevalent of which is solar energy. Solar energy has negligible environmental impacts, and we have a massive untapped amount of it until the sun explodes, which neither of us will be here to see.
Most homes in the United States do not effectively use solar panels to their maximum potential. Most homes do not know when their solar panels are producing the most energy. This leads to them using their electronic appliances at times that would not just take energy from their solar panels, but also from the grid as a whole, which leads to you spending money and leaving a carbon footprint. But don't just take it from us. Alright, so I got a couple questions for you. Do you ever feel like you waste too much solar energy because you don't time your projects perfectly?
Yeah, honestly, I feel like I do, brother. Like, I'm not gonna lie. I feel like I do. For
Really?
sure.
Okay. So, if an app can automatically tell you the best time to run appliances and save money, would you use it?
Yeah, for sure, man. I mean, I'm definitely looking for something like that.
Alright, thank you.
To solve such a massive issue, we have created the Solar Optimizer, which is part of our SolarSync app. It helps you plan home energy use around real sunlight and weather, so you can run appliances when solar power is strongest. First, set your location. You can use your device's geolocation, like this, or you can even set a city, such as Glendale, or even an address. You can also even use coordinates. Once set up, the app pulls today's weather and builds a solar forecast for every 15 minutes. In the main chart, you'll see two curves. The yellow underlay shows perfect conditions, what your solar could look like on a clear day. And the green curve adjusts for today's weather, such as temperature, cloud cover, humidity, or UV index. So it reflects real conditions. This makes it easy to see the gap between ideal and actual prediction. Below, we highlight the peak solar hour and the best continuous 4-hour window. We also show the current solar level. So right now it is 819 and it's dark outside, so obviously there is 0 watts per meter squared. However, when it is around 12 o'clock, it will be around 180 to 240 watts per meter squared. And how it compares to today's peak, so you know if now is a good time to run something energy intensive. Smart scheduling, as shown below, uses today's solar window to suggest start times for common appliances, such as your washing machine, your dishwasher, your dryer, etc., and staggers them so you're not stacking loads at the same minute. There's also an appliance assistant. You can ask when to run a specific appliance today, and it gives concise recommended time windows based on your local solar profile. It works even without external APIs, using the app's built-in model of your day's sunlight. Everything is calculated locally on your browser, and the results are estimates to help you with planning. And they'll vary with your location and timing. If you change location or refresh weather, the chart and recommendations update automatically. So if I change it to New York, the chart changes. So that's it. Set your location, see today's solar forecast, and run high-draw appliances during the best sunlight to reduce grid use and costs. We built a fully client-side solar power optimizer with over 1,000 lines of code within Visual Studio Code using vanilla JavaScript, structuring the app around a single orchestrator class, which is Solar Optimizer, that manages state, input, output, and rendering. The app wires up to event-driven flows for location acquisition, such as browser geolocation API, manual latitude/longitude, or address geocoding via nominatim. Then derives a lightweight time zone offset from longitude to avoid server dependencies. This keeps the runtime 0 backend and deployable as static assets while preserving a clean control surface for user inputs. The Solar Engine computes a per-day irradiance profile at 15-minute resolutions per driving the equation of time to get local apparent solar time and hour angle. We compute solar altitude via standard trigonometry, solar modeling, and solar modeling happens in calculate solar data, which samples in every 15 minutes across the day. For each timestamp, we convert altitude to irradiance in calculate irradiance, applying a simple atmospheric model, and then adjusting for weather, such as clouds, temperature, humidity, UV. In apply weather adjustments, the chart is drawn with a Canvas 2D API in render chart, with which we draw the axes and grid. Peak hour logic in the function display peak hours finds the absolute peak and a best continuous 4-hour window using sliding averages of over 16 samples. Update appliance recommendations, staggers appliance times with within that optimal window and formats them in 12-hour time. The assistant button calls the function Ask Appliance Assistant, which summarizes today's appliance and by default returns a local heuristic suggestion aligned to the best window. One issue that arose was visualization issue, where very low weather-adjusted irradiance made the chart look flat and misleading. To fix this, we now compute a theoretical perfect sky curve and scale the chart using the maximum theoretical versus adjusted irradiance so the shape stays readable even on gloomy days.
We waste so much potential energy every day, not because we don't care, but because we don't have the tools to use it wisely. Solar energy is clean, abundant, and already paid for. All it needs is smarter timing and smarter choices.
With SolarSync, we make those choices effortless. Join us in using the sun smarter. Save energy, save money, and help build a cleaner planet, one appliance cycle at a time.
I've been Nihal.
And I've been Sid. Thank you so much for listening to our Congressional App Challenge submission for 2025. SolarSync out.